Hi guys, welcome to today's tutorial. Today we'll be looking at quotient rule. Okay, in our previous video we've studied product rule and sum and difference rule. So a continuation of the video is our quotient rule. Okay, stick with us as we go right through it with examples. Now, it says, given that y is u over v, then for us to solve our u over v with respect to x, then we are going to apply our quotient rule, which says the y dx equals v over du dx minus u over dv dx, all divided by v squared. Now, let's look at an example here. Now, if our y is x minus 2 divided by 5x minus 6, now this, let's equate to u and v. That means our u here is x minus 2. Now, du dx, differentiating this will be what? 1. Okay, so when we differentiate this becomes 0 and this becomes 1. And the v is 5x minus 6. So dv dx equals 5. Okay, now imputing this, since our quotient rule says v du dx, so our v is what? The y dx equals v is what? V is 5x minus 6 times the u dx. The u dx is 1 minus u is x minus 2. The v dx is 5 all over v squared, which is 5x minus 6 squared. Okay, now having done this, let's expand 5x minus 1 the y dx gives us 5x minus 1. Okay, now opening this bracket, we have minus 5x minus 10 all over 5x minus 6 all squared. Okay, so this gives us 5x minus 1 minus 5x plus 10 all over 5x minus 6 squared. So from there, this is 5x minus 6, 5x minus 6. Okay, so 6 minus this will give us 4. So this will be 4 over 5x minus 6 all squared as our answer. Okay, if we have x squared plus 1 all over y equals x squared plus 1, x plus 1 all squared, and we have to differentiate this. Okay, if we have to differentiate this, u is x squared plus 1, so du dx will be 2x, and our v is x plus 1 raised to power 2, so dv dx would be 2 bracket x plus 1. Okay, now applying our quotient rule that y equals v du dx minus u dv dx all over v squared. Okay, our v is x plus 1 squared times the u dx 2x minus v x plus 1. Okay, our u is x squared plus 1, x squared plus 1 times 2x plus 2. Okay, that's this times 2x plus 2 all over our v now is x plus 1 raised to power 2 all squared. Okay, so if we expand this, if we should expand this, or we can say, let's leave this as x squared plus 1. Okay, so we can factorize here. We have x plus 1 as a factor out times x plus 1 times 2x minus x squared plus 1 times 2 all over x squared plus 1 raised to power 4. Okay, now doing that, we can now cancel 1x plus 1, x plus 1, sorry. One of this, we cancel one of these, leaving us with 2x bracket x plus 1 minus 2 bracket x squared plus 1 all over x plus 1 raised to power 3. Okay, now expanding this, we have this as 2x squared plus 2x minus 2x squared minus 2 all over x plus 1 raised to power 3. So 2x squared will cancel 2x squared, leaving us with 2x minus 2 all over x plus 1 raised to power 3. So this gives us factorizing 2 bracket x minus 1 all over x plus 3, x plus 1 raised to power 3. Alright, so with this, we've differentiated y equals x squared plus 1 over x plus 1 all squared. Okay guys, if there are any questions thus far, don't forget to put it down in the comment section. And please also like, subscribe, and click on the notification button, for it helps our channel to grow. Share this link with your friends if you've enjoyed our lecture thus far. For our question 3, it says if y equals 5x raised to the power 6 plus 3x cubed minus 1 divided by 3x raised to the power 3. Now that we should find out the y, the x. Now, in order to find the y, the x, or differentiating this, we are going to use our quotient rule, which says that y equals v du dx minus u dv dx all over v squared. And in this case, our u is up 1, our numerator 5x raised to the power 6 plus 3x cubed minus 1. So du dx will be differentiating this 30x raised to the power 5 plus 9x squared, while our v is the denominator 3x cubed, dv dx gives us 9x squared. So applying our quotient rule here, this becomes 9x squared, the y, the x equals 9x squared times 30x raised to the power 5 plus 9x raised to the power 2 minus u is 5x raised to the power 6 plus 3x squared x cubed minus 1 times 3x cubed. Okay, and that v will be 3x cubed all squared. So this gives us, expanding this, 30 times 9. Sorry, our v is 3. Sorry, 3x cubed. Okay, so 3 times 30 gives us 90 x raised to the power 8 plus 27 x raised to the power 5. This times this minus the v dx will be 9. So this should be 9 squared. Okay, so 5 times 4 gives us 45 x raised to the power 8 plus 27 x raised to the power 5 minus 9x squared. Alright, so guys, we need to be very careful when imputing our values. You can see I practically made some errors changing my v to be dv dx and my dv dx to be my v. So we need to be careful when imputing these figures, okay, in order to avoid errors. Okay, expanding this from here, we have this as 90 x raised to the power 8 plus 27 x raised to the power 5. Expanding this, we have minus 45 x raised to the power 8 minus plus times minus minus 27 x raised to the power 5 plus 9x squared all over 9x raised to the power 6. Okay, so from here, 90 minus 45 gives us 45 x raised to the power 8. 27 will cancel 27, leaving us with plus 9x raised to the power 2 all over 9x raised to the power 6. Now, since this is shareable to both of them, we can simply share it and say this to be, okay, we can say this to be 45 x raised to the power 6, x raised to the power 8, all over 9x raised to the power 6, plus 9x squared, all over 9x raised to the power 6. Okay, so from here, we have it as 9 here, 1, 9 here, 5x, 8 minus 6 will give us 2, 5x squared, plus 9 will cancel 9 to leave us with 1 over x raised to the power 4. Okay, so with this, we can say we've differentiated this as 5x squared plus 1 over x raised to the power 4. Or we can write this to be 5x squared plus x raised to the power minus 4. We can write it to be this. So we are still correct. So with this, we've solved our question. Next, we'll be looking at is a chain rule. Okay, for chain rule, y is a function of u and u is a function of x. So we apply what we call functions of function. Okay, so for example 1, our chain rule is saying that the y, for us find that the y dx, then the y over du times the u over dx. You can see the u will cancel out, still giving you the y over dx. Now let's look at the example. Since y is a function of u and u is a function of x, so in this case we can say that y equals u raised to the power 3. Okay, so if we differentiate this becomes 3u squared. Okay, let's call this as the y du. Okay, so if y equals u raised to the power 3, so the y du equals 3u squared. Alright, and u is what? Okay, let's start with let u be 2x minus 5. Okay, our u is what's in the bracket, 2x minus 5. So if our u is 2x minus 5, all right, then the u, the x would be what? 2. If we differentiate this, we'll get 2. Okay, now applying to our law, where we say the the x is dy du, which is 3u squared times du dx, which is 2. Okay, so this gives us 3 times 2 will give us 6u squared. Okay, remember the value of u is what? 2x minus 5. So this becomes 6 brackets 2x minus 5 all raised to power 2. So with this, we've differentiated our question. So our second question, it says if y equals 2x plus 3, something very similar, raised to power 5. So we can differentiate this using chain rule. We say let u be 2x plus 3. So du will be what? Since this is equals to y, this will be a y. Okay, let's start with y before we go to the y du. A y will then change to u raised to power 5. Then the y du would be, 5 raised to power u raised to power 4. 5 times u raised to power 4. Okay. Now, since our u is 2x plus 3, so the x would be, differentiating this will be 2. Okay, so now bringing a product rule that says the the x is a function of the y over du times du over dx. So this gives us the y du here is 5u raised to power 4 times du dx is 2. So this gives us 10u raised to power 4. But remember that u is what? U is 2x plus 3 all raised to power 4. So with this, we've differentiated our question. Okay, now let's look at this. It says y equals 3x cubed minus 5x raised to power minus 3. So we have to differentiate this. And differentiating this becomes y will become u raised to power minus 3. Okay, now where are u? U equals 3x cubed minus 5x. Okay, that's our u. So here, our dy du would be minus 3 u raised to power minus 4. Remember, in differentiation, you are having it as a x raised to power n. This becomes a n x raised to power n minus 1. Okay, all right, a times n times x raised to power minus 1. So when we bring a minus 1 minus 3, it will give us a minus 4. Okay, that's for the y dx. Then du dx would give us 3 times 3, 9x minus raised to power 2 minus 5. Okay, that gives us now our chain rule says the y, the x equals what? Dy over du times du over dx. Okay, now the y du is minus 3u raised to power minus 4 times the u dx is 9x squared minus 5. Alright. Minus our u here is what? Minus 3 bracket u is what? 3x cubed minus 5x raised to power minus 4 times 9x squared minus 5. Okay. Our next question is y. Differentiate y equals 2 root 2 bracket and 2 times, let's call it 2 times root 4 minus x. This we can write as 2 bracket 4 minus x squared raised to power half. Okay, we can write as this. So here we can say u, let u be 4 minus x squared. So our du dx will give us, differentiating this will give us minus 2x as our differentiation. Then y equals 2 u raised to power half. Okay, 2 u raised to power half. Differentiating this, we get the y dx to be 2 times half times u raised to power half minus 1. This gives us 2, 2 we cancel 2, leaving us with 2 raised to power minus half. Okay, so now bringing our chain rule that says the y dx equals the y over du times du over dx. Okay, here we now have it as the y dx is u raised to power minus half times du dx is minus 2x. Okay, minus 2x. Bringing our u here, our u is what? U is 4 minus x raised to power minus half times minus 2x. So you can write this to be, since we have a negative index, this can be minus 2x all over 4 minus x raised to power minus half, raised to power half, or we write it as minus 2x all over root 4 minus x. Okay, so with that, we've differentiated our questions. Alright guys, with this, we've come to the end of today's tutorial. Don't forget to like, share this link with your friends and your fellow colleagues if you've enjoyed our lecture thus far, as this helps us to grow. Click on your notification buttons to get updated whenever we upload a new video. In our next class, we'll be looking at differentiations of our trigonometries. So ensure you do not miss it. Click on that notification button to get updated once it's uploaded. See you in our next class. Thank you.